Hello everyone, my name is Manuel Esparza and I'm going to be helping you learn all about the quadratic formula and the discriminant. Sometimes you have a quadratic equation and if you're lucky you can solve it pretty easily. Like when you have a calculator that can do it for you, or if the factors are easy you can just do it in your head. But life's not always that easy for us poor math students. And sometimes you have big numbers or fractions or terms that don't factor in the equations, which make it difficult to do. But don't worry, that's why we have the quadratic formula in our toolbox. Let's start with some basic knowledge you will need to know about the quadratic formula. Here's the general quadratic equation that you will be using. ax squared plus bx plus c is equal to 0. Now begin by identifying the coefficients a, b, and c. Now here is a in the red color. Here's b in the blue color, and finally we have c in the green color. Now you're ready for the quadratic formula. The formula is x is equal to negative b plus or minus the square root of b squared minus 4 times a times c over 2 times a. Let me give you a study tip. The formula seems long, but this is one that you will need to memorize. Try writing it down 10 times and then try to say it from memory. Once you get good at it, it will almost be like a little song. We tend to remember songs for whatever reason. You will need to know about the term discriminant. This is just the value of the expression under the radical or square root sign. B squared minus 4 times A times C is a discriminant. Let's talk about the roots and the discriminant. One thing to know here is that you can use the value of the discriminant to determine both the type and the number of roots. For example, if you plug in b, a, and c in the discriminant part, do the math, and the answer is greater than 0 and a perfect square like the number 16, then you will have 2 real rational roots. If the answer is greater than 0 but not a perfect square, then you'll have 2 real irrational roots. Next case, if your answer is equal to 0, then you will only have 1 real rational root. Last case, if your answer is less than 0, like negative 2, then you'll have 2 complex roots. Okay, let's get into the fun part where we start using quadratic formula. Here's our first example where we are going to have rational roots. Let's take the equation 2x squared minus x is equal to 15. The first thing you will need to do is put it into standard quadratic form. So let's move the 15 over to the left side and it becomes a negative 15. Next step is to identify a, b, and c. In this equation, a is equal to 2, b is equal to negative 1, and c is equal to negative 15. Ready? Now let's plug the values into the quadratic equation. Here we will put in negative 1 for b. Here we will put in negative 1 for b. Put in the 2 for a and the negative 15 for c. And last, plug in the 2 for a. Let's stop and talk for a bit about common error of messing up the signs of the coefficients. I like to put everything in parentheses like you can see here. This helps keep all signs right. Now let's solve the equation. The negative of the negative 1 will give you a positive 1. The negative 1 squared will give you a positive 1. The 4 times the 2 times the negative 15 gives you a negative 120. And the 2 times the 2 gives you a 4. Then 1 minus a negative 120 gives you 121. Then simplify. The square root of 121 is 11. This brings us to another common error. Don't forget that you have a plus or minus here in your quadratic formula, so you have 2 equations now. X is equal to 1 plus 11 divided by 4. The other equation is x is equal to 1 minus 11 divided by 4. You get 12 over 4 here and 10 over 4 here. Your final solutions are 3 and 5 over 2, which are two real rational roots. Next, we have an example where you will get irrational roots. Let's take x squared minus 4x minus 3. Now identify a, b, and c. So we get a is equal to 1, b is negative 4, and c is negative 3. Let's plug them into the equation. Okay, so negative of negative 4, you'll get positive 4. Negative 4 squared is 16. 4 times 1 times negative 3 gives you negative 12. But you have a minus of a negative 4 or negative 12, so that becomes positive. At the bottom, you have 2 times 1 to get 2. Now you have 4 plus or minus square root of 28 all over 2. The 28 can be factored into a 4 and a 7. You take the square root of 4, which is 2, and move it out here. Next step is to simplify further, but let me point out another common mistake here. It is easy to see that the 4 can be reduced by the 2 in the denominator, but you must also do that to this term here. I have seen this mistake a few times. Our final answer is 2 plus or minus the square root of 7, which are two irrational roots. Our last example will be one with complex roots. Let's take negative 2x squared minus 8x minus 10 is equal to 0. A will be negative 2, B will be negative 8, and C will be negative 10. Plug them into the equation. Doing the math, we get 8 plus or minus the square root of 64 minus 80 over negative 4. That turns into 8 plus or minus the square root of negative 16 over negative 4. So, the square root of negative 16, a common mistake is to stop here because we may not remember what to do with the square root of a negative number. Well, if you remember previous sections, here is where we use the imaginary unit I. You can continue since 4 is the square root of 16 and put the I since it was a negative number. Now we have 8 plus or minus 4i over negative 4. We can further simplify by dividing both terms by 4 to get the answer of negative 2 plus or minus I, which is a complex root. Let me summarize what we have learned today. We covered key terms and concepts such as quadratic formula, discriminant, how to tell the numbers and type of roots, and the examples of how to use quadratic formula to get solutions to our equations. Okay, that's it. Easy, right? One last good tip to develop good study habits. Try using the quadratic formula to solve equations that you have already done by factoring or other easy methods. Check that you get the same answers. This should help prove that the equation always works as well and helps you memorize a quadratic formula song.